SignalR is an excellent way to connect two or more clients together for real-time communication. The best part is that this library is a wrapper around web standard technologies such as WebSockets and long polling. It just makes them easier to use. That means we can even use SignalR with other clients such as Java or JavaScript. In this video, we're going to learn how to set up SignalR and how to connect to it using web clients and desktop clients. Throughout the video, we'll cover best practices as well as how to use this in the real world. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier. I do that by providing videos here on YouTube multiple times per week, plus I have a weekly podcast. I also provide courses on C#, web development, and much more on IamTimCorey.com. The profits from those sales are what pays for the free content here on YouTube, so that everyone can have a great education in C#, not just those who can afford it. In this video, as with most of my videos, I'm going to create some source code. If you'd like a copy of my source code, use the link in the description. All right, let's go to Visual Studio. And we're going to start by creating a new project, and we're going to choose a Blazor server app for this. And we're going to say that this is the Blazor server. Let's call it Blazor server. And we're going to say this is the Blazor server app. Well, let's call it the SignalR app. All right, and we're going to hit next. .NET 6, we're going to use no authentication, yes to HTTPS, no to Docker. Hit create. And we can use pretty much any of the web project types for hosting our SignalR. This is going to be both a host and a client. Now let's actually move my tabs to the left and move them to the top. I prefer them up there. Okay, so now that we have our Blazor server app open, let's go to the right-click on properties. Right-click on dependencies and say manage NuGet packages. And we're going to search for a NuGet package called microsoft.aspnetcore.signalr.client. That's this one right here, not the core version. Client uses the core version. If you notice down here under dependencies, you'll see that it uses the core version, but that it adds things to it for connecting using the from URL, which we'll use in this demo. So we're going to use the full client, not the core version of it. Don't get confused by the word core there. It doesn't mean .NET Core. These are both work with .NET Core. The difference is that this means just the basics, whereas this means the full client. So we're going to choose the latest stable version and install this. Hit I accept, and we're done. And now we can start setting things up in Visual Studio. Now, again, this is going to be both the server and the client. And we're going to follow along with, this is actually a slightly adapted version of what you're going to get right in the Microsoft Docs. Now, we're going to start with that, and then we'll start changing things as we go to better understand how this all works. So what we're going to do is we're going to right-click on the Blazor server and say add, new folder. We'll call it hubs, plural. Right-click on hubs and say add class. And we're going to call this class the chat hub. This is kind of the basic standard demo that everyone does when they start building out SignalR. Again, SignalR allows for real-time communication, so the most obvious thing would be chatting, where you can have a message that everyone can get. So you say hi, everyone gets hi, they can reply back and forth you go. It's a great stand-in for showing you the connectivity issues and so on. However, by the end of this video, we will use a different hub that will not just send text over, we'll actually be sending over information for our counter page. And we'll change the counter value based upon the information we send in. So we will get to doing new cool stuff with this, not just a basic chat application, which everybody does. But we're going to use this as a stand-in to get the basics out of the way and understand what SignalR is and how it works. Now, I don't like the this namespace setup. I like to have the file scope namespace. So I'm going to do that, but then I'm also going to right-click on solution and say add editor config. It always errors out like that, but you open it back up and it's fine. Go to code styles and change from block scope to file scope on namespace declarations. That's all I'm going to change, but that way any new file we create now should have this setup. Okay, this is the chat hub. We need to have a using statement here for using Microsoft.ASP.NET Core.SignalR. This is the newer version of SignalR. So there is an older version, but this is the newer version of SignalR. And again, just to be clear, SignalR is just a wrapper around WebSockets. It also has fallbacks, which are server-driven events, I believe it's called, and then long polling are the two fallbacks. So what happens is WebSockets, it's a industry standard thing, not a Microsoft thing, but you can connect two clients together over the web using WebSockets if they both support it. And then if there's a problem, like maybe there's a temporary internet glitch, something like that, you'd want to have a reconnect ability. SignalR allows you to do that. So it allows the setup, it allows the reconnect, it allows for a lot more things that it's doing that's kind of making life easier for you on the C# side. Think of it like Dapper, but for connecting the clients together. It's a wrapper that makes life easier. Okay, so we have our chat hub. This will be the thing that we talk through. We're going to have one public task called send message. And in here we'll say string user and string message. And we need to also inherit from hub. There we go. And this is going to return clients.all send async user message. Oops. And we also are going to give it a name, receive message. Okay, so what's going on here? Well, this is the kind of like the server. And so when we say, hey, when something calls, and we'll see where we're going to call this, but when something calls the send message method, we're going to pass in a username and a message. What are these two values? Anything you want it to be. So it could be Tim and hello world. It can be a GUID and, I hate GUIDs. I don't know. But those two values where you pass into this method. When that happens, it's going to figure out which clients are connected. And it's going to say, hey, I want every client to get this message. And it's going to say, here's the message type, receive message. So this is the message type. This is the type of data that's coming through. So this is the receive message type. And here is the data that's associated with that message. There's the user and the actual message itself. Okay, so that's all it does. Now, this implies a few things. First of all, we can have more than one client connected to the server. And yes, you can have lots of clients, thousands of clients connected to the server. The cool thing here, just so you know, is that your web server can handle thousands of connections, tens of thousands potentially of connections. At some point, it's going to get too large though, where maybe you want to connect 100,000 people at once. That's probably unlikely because it's at once. It's not during the day, different times. It's at once. But let's just say you did. Well, you can offload this to SignalR on Azure and scale this up and allow that. So if you ever did get to that point where you're like, man, I want to have this connectivity, but I've got tens of thousands, maybe even hundreds of thousands of connections at a time, well, then you can scale it up to an Azure Azure account and scale this out. Now, so that means multiple clients. All indicates we don't have to send a message to everybody. We can send it to certain clients or only one client. So this is just saying send it to every client. But again, we could send it to just a few. And then send async just means we're going to trigger this receive message on every client and pass in this data. And that's going to do it asynchronously. All right. So that's what the hub is. Really simple. It just has one method. We'll see how to add more hubs and different messages later on. So that is the chat hub. Now that we have the chat hub set up, let's go to program.cs and configure this. And we'll talk through the parts that we need. Now we need to add a using up here. Let's get rid of the things we don't need. Let's add a using for Microsoft.ASP.core.response compression and using SignalR, using Blazor server dot hubs. All right, now we're set to start configuring. Now we're not going to mess with the defaults that are already built in here, but this is our section in the program.cs. And if you're confused as to why there is no setup.cs, I did a video on that. This is just the .NET 6 stuff where they put setup.cs and program.cs in the same file. That's all it really is. So here is our services set up for our dependency injection. So we're going to add one more service. Builder.services, not Razor Pages, add response compression. And we're going to say, let's set up some options. And in here, we're going to say options.mime types equals response compression defaults dot mime types dot concat. And we'll talk about what this is in just a minute. Once I'm done, new array. And we're going to say in here, application / octet stream. Make sure you spell that right. Okay, so what are we doing here? Well, if you're familiar with web types and web servers and how they run, they need to know how to process various types of data coming to them or coming out of them. And so this right here says, hey, let's make sure that our web server has the ability to process octet stream. Okay, so that's what this is doing, and it's adding compression to it. All right, so it allows to add this response compression, which means that the connection for SignalR is very, very small, so that it can be as optimized as possible. So it's just making sure that we configure everything to properly talk to our web server. All right, so with that being done, we need to come down here to after our map Blazor hub, which, by the way, that's SignalR. Map the Blazor SignalR hub to the default path. This is Blazor server, which remember that Blazor server kind of sits on one foot on the server side, 1 foot on the client side, where it runs server side, so we can have secure code in there, talk to a database and so on, but yet it looks like a client side application in that when we hit the button on the counter, it increments without reloading the whole page, because it uses SignalR in the background to talk to a JavaScript library in the front end that enables that linking between our page and the backend code. So we already map a Blazor server hub. Now we're going to say app.map_hub and give our own hub, which is chat hub. And we're going to give it a path. So how do we connect to this? What's the URL to connect to our chat hub? Well, let's call it chat hub. That's pretty typical. So now if we go to our website and say /chat hub, we can connect to that SignalR connection. Now you can't just go there manually. We need to use a client to go there, but this will allow us to connect to that, that location. All right, now let's go to our index page. And here's where it's going to get a little interesting. And that's because we're going to have both the client and the server on one page. And that can get confusing at times because you're saying, wait, you're sending a message to yourself, right? Well, yes and no, because remember that a web page isn't opened by just one person. So if you open a copy of this web page and I open a copy of this web page at the same URL, then when I put a message in, you will see it. And when you put a message in, I will see it. So we're going to see that first. That's kind of the standard basic demo stuff. Then we're going to break apart and have actual clients and actual servers. So let's get rid of all the standard stuff except for the actual page directive. We're going to add a using statement at the beginning. Using Microsoft.ASP.core.SignalR.client. We're also going to inject using dependency injection, navigation manager. And let's call it nav manager. And implements iasync disposable. So we can actually asynchronously dispose of this when we go off the page, which means disconnect from our hub. Now let's go down into the code. So let's put a section here for @code. We'll start here and say private, if I can spell right, private hub connection, and that's nullable. Let's call it hub connection. And we're going to have a private list of string, and that's the messages, equals new. Now, this right here, this is going to connect to our hub, which again is on this same web server. But this right here will be a list of all the messages that we get from chat. So we'll be able to display that on the page. And then we're also going to have private string user input and private string message input. And we could make those nullable too. Let's just do that. Strings are nullable, but this right here says, yes, I'm acknowledging that this could have a null in it, and that's okay. That's the difference there. So now that we have these in place, let's go up here and start writing just a little bit of code here. So we're going to say div, sorry, not code, HTML, class equals form group. This is going to be a really ugly form, that's okay. Label, we're going to say user input at bind equals user input. And let's self-close that. So that's going to bind to this string right here. And we're not using the real, like, we could be doing actual text input and all the rest, the newer Blazor stuff, but we're just going to use a quick label here just to get something going. Whoops. We're going to copy this and we're going to paste it again. And we're going to say, this is the message. And this will be the message input, like so. And then we're going to have a button with an on click equals, and we don't have a method for this yet, but we're going to say send. And then we'll say, we're going to have, I'm following the example on Microsoft site here. So we're going to do this just to see how it work or how it look. Disabled equals not is connected, or is connected equals false. Notice I don't I'm not a big fan of the not here, just because it blends in so easily. So you could also say equals false. So if that is the case, it will be disabled. So you have this button here that's going to say, hey, it's disabled if we're not connected to our hub. We don't have a is connected yet. We'll get that in a minute. And we have this idea, once we click the button, if it's not disabled, it's going to send our message. So we'll supply a user. We'll supply a message. We'll click send, but only if we're connected to our hub to actually send the message. All right, so now down here in the code, we need to write some more code. Protected override on initialized async, which we need to make async task. Get rid of the standard code there. And instead, we're going to connect to our hub when we have our oninitialized async. So we're going to say hub connection equals new hub connection builder. And we'll do it on the next line. Dot with URL. That's what remember I said that the core version of the NuGet package we looked at didn't have this particular method on it. So you have the full version. Nav manager. That's the item we brought in with dependency injection. So that's right up here on line 3. So nav manager, and then we want to say to absolute URI, and we give it our path to our chat hub. Which what we're doing here is saying, hey, you're the navigation manager. You know what the URL is for our website. So just grab that URL, using this path, including this path. So it's localhost : 1234, whatever it is, /chat hub is what it'll come out with. And then we're going to have a with automatic reconnect and a build. So what this does, it creates a connection to our hub. And the connection is to the /chat hub specifically, which again, if you go to program.cs, right there, that's our hub, and it's of type chat hub. So that's how we connect. This is the client side part of it, or on the client side, connecting to our hub and saying, this is the hub I want to talk to. This automatic reconnect here, this is really cool. We're going to see this when we implement the WPF client, the desktop client. What we're going to do is we're going to take this off and show a difference. But essentially what happens is if there is a problem with the connection, which happens, your internet glitches for a minute, maybe you switch from Wi-Fi to cellular, or maybe, whatever it is. If you need to have this constant connection, which is what SignalR does, it keeps the constant connection open, very, very tiny little packets back and forth. It basically just pings back and forth. But if that connection gets lost and you don't have this line, then you've disconnected from the server, you need to reconnect. But with automatic reconnect, it does exactly what it says. It's going to try to automatically reconnect to the server. Now, by default, if you don't give it any times, which I haven't, then I believe it connects, or it tries to reconnect immediately. And then after 2 seconds and 3 seconds, 10 seconds, and 30 seconds. And so that's almost a minute where it's tried like 5 or 6 times, I think 5 times. And if it doesn't connect after that, then it closes the connection. But at least it gives it a shot. Now you can change those times and say, hey, I want it to be every 5 seconds for a minute. Cool, go for it. Whatever it is, it will try to reconnect and find the server. If you have a spotty connection that comes and goes, it will reconnect. All right, and then build just actually uses the hub builder and does the connection with this information and sets that connection up. Now, we haven't started the connection yet, but we've built the connection. Now, we're going to start the connection in just a minute, but first, I want to capture an event first. That way the event is set up before we connect to the server. So hub connection on, and the type is string string. Now, how do I know it's type string string? Well, because our chat hub, string, string. Those are the two things that are the two data types that are sent with a message. So it's string string, and we're going to say it's a receive message. Type this correctly because this is this right here. It's a string, but yet it corresponds to this. So when the chat hub says send to all clients a receive message, and you have a receive message right here, this will be triggered with the two data points that are coming in are the user and the message. So make sure that it matches up. Then we're going to use an anonymous type here or anonymous method and say user and just user and message. Whoops, I closed it too early. Sorry. User and message, and then arrow. And let's go to the new line with curly braces. So in here, we're going to say var full or formatted message equals, we'll do a string interpolation here and say first user colon space message. Okay, so we're just creating a new string that is the combination of user and message with a colon in between. Okay, now we have this, we're going to say messages dot add formatted message. Remember that the messages is a list of string which we're going to display on the page and say, hey, here are all the messages that we've received. And then we're going to do an invoke async state has changed. Now, what's this doing? Let's first of all put the close paren and the semicolon. What's this doing right here? Well, because the fact that this is captured on an event and we changed values that this page will need to see, since it happened, we need to tell Blazor, yeah, something happened on the page. You need to check for new values. Because otherwise, it might not display those new values until something else changes on the page. So what we do is we say state has changed. And we're invoking that asynchronously. So what this is the client side. This is the receiver of the message. So this is what captures messages from the server. So the server is this, send message. That's all a server does, really. And we initialize that on the program.cs. So that's the whole setup for the server side. For the client side, we're going to listen for messages from the server on this particular type. Now, we don't have to. If we are not listening for this particular type of message, we just won't get it. Everybody else will, but we won't process it. Our connection will get it, and the connection will say, hey, I don't have anything to do with this, therefore I just ignore it. It's kind of like click events. If we don't have any wired up to them, well, then nothing happens. Now, we still haven't connected to us or haven't set up the connection. I'm sorry, we set up the connection. We haven't actually connected to our server yet or our hub. So await hub connection dot start async. And that's a lowercase h, which is why it was yelling at me and not giving me IntelliSense for that. So we're going to start our connection. We can wrap that in a try catch, but I think this is fine for our demo. But again, we'll see wrapping this in a try catch in our WPF app, again, just for more safety and ensuring that it actually does start, because what if the chat hub wasn't there? Now, it should be, since we're on the same web server as the hub. We're actually in the same project as the hub, but just because something should be there doesn't mean it is going to be there. So again, we'll see more about wrapping that in a try catch and how to do that in a future part of this demo. So we've now got a connection open to the server. We're not done yet, though. We still need to have the send and it's connected. So let's start with the private async task send. And in here, what we're going to do is we're going to say if hub connection is not null, meaning we have a connection, then in here, we're going to say await hub connection dot send async send message. Does that sound familiar? And we're going to say user input and message input. So send message, notice it's a string, send message. If we go back up to our chat hub, is the name of our method. So that's the connection there. This is going out to the server and saying, hey, trigger this message to go to everybody. So broadcast this. So we're saying, this is the method I'm going to call on the hub, and I want to give you these two pieces of information, which happen to be two strings, both first the user and then the message. The server, the hub, says, cool, got it. Okay, every client, I want you to receive this message. So here's the type of message, receive message, and here's the data which was provided by this send right here, which means that when we send a message, we're going to trigger this method right here, which is an event, which is going to capture the receive message event, and we're going to capture the user and the message and print them out. Notice this is not user input and message input. It's not the things on the form, it's the data we got back, which means we could get this from a different version of our web page. Okay, now let's get the is connected, which I'm going to do exactly the same thing that we did on the Microsoft help page, just to show you is connected, and it's a simple lambda that says hub connection. I hate how it does that. Hub connection, if it's not null, give me the state equals hub connection state dot connected. So it's saying, hey, the is connected is going to be if the state is connected, then yes, it's connected. So if the state equals connected, then it's connected. Otherwise, it does not equal that, therefore it's false. And lastly, we want to have a public async value task of dispose async. And this is, remember back up here, we said implements iAsync disposable. That interface, well, that interface has one method on it, and that is dispose async. So when this page gets closed, we're going to have this method run, and we're going to say if hub connection is not null. So if there is a connection, no matter the state, await hub connection dot dispose async. So it's going to close down and properly dispose of our hub connection. All right, we're almost there. The last thing we need to do is go back to our HTML. We've got the form. Okay, so user input and the message input and the button. But now below that, let's put a horizontal rule, and then below that we're going to have an unordered list. And what we're going to do is inside of this unordered list, we're going to say at for each string message in messages. And then inside here, we'll have a list item for each message. So this just loops over our list of string, which is all of our messages from the chat hub. We're going to loop through all of them and put them in an unordered list. So we're just going to show all of our messages. That's it. On this one page, we have all the client stuff set up. We have connected to the hub, which we set up that connection. We set up the event that happens when we're going to listen for the listener for the received message event. And we set up the method to send a message to the hub. And then we also handle the disposal of this page. Let's launch this and see it in action. And to do this, we're actually going to launch it twice. So let's launch it. It comes up, and I am going to just put it right like this. And then let's copy this. I'm going to create a new instance of, let's do an incognito window just to show that it's definitely different. And now I'm going to log in. Let's say this one's Tim and hello world. Let's zoom in here a little bit on both of them so you can see a little closer. Hit send. Notice both screens say hello world. And if this is Joe and I can say hi Tim, it says on both screens. Okay, so we've got the message on both sides, and that's how SignalR works. There's a connection there where both screens have it. Now, if this screen right here, the incognito window, was actually halfway around the world, it would still work the same way as long as we were on an actual web server, not localhost. But this allows for real-time communication. Now, the first and most obvious, like we've done here, the first and most obvious thought is, cool, it's a chat app. And that's all I can think of that it could do. But there is so much more that this could do. If you wanted to create a small interactive game in Blazor, where you have users connect to each other, maybe not to everybody, maybe just to each other, you could do that and have real-time communication back and forth for moves on a board or whatever you want. You could have information where maybe every Blazor client is consuming a values from a stock ticker or from a database. Maybe there's a real-time charting going on where you're sending information for charts down to every Blazor server client so they can all see the latest information. Or maybe you have an event where you create an auction and you want to show in real time what the auction value is without refreshing the page, having this happen automatically. eBay does this, I believe, in the last few minutes of an auction where that value is live. The page doesn't refresh on a period. It's just automatically refreshed every time the auction value changes. So they only do it in the last few minutes because it could be a real connection issue. But for short periods of time, that's great. So there's lots of potential here with these connections. So let's close out this one, which will close out the connection to the server because this one has the hub. And if we do that, attempting to reconnect to the server, we can't reconnect because there is nothing there because the actual web server is down. So we're going to see more about reconnecting. It's hard to show reconnects with the web server when it's a client too, because it's both the client and the server. But we're going to show that with WPF in an independent client. So we'll see that in a minute. But first we have to have a client to talk to. So let's shrink these things down and we're going to right click on our solution. Actually, let's close out our two values here first. Right click on a solution and say add new project. I'm going to choose WPF application and we're going to call this our WPF client. It's just a client. It's not the server too, just a client. And yes, .NET 6. So now we have our client and we need to then, before we do anything here, we need to right click on dependencies and say manage NuGet packages. Go to browse, Microsoft.asp.core.signalr.client. And you may say, well, wait, ASP.core? Yes, ASP.core, because we're going to talk to a web server. So therefore, we need the ASP.core SignalR client. The Microsoft.asp.core.signalR, that's the newer version, the newer iteration of SignalR. So yes, install this, not the core, the full client. And hit OK and accept. And once that's done, we can close out of the window and come back over here to our XAML. Now, some of you may not like XAML. I understand. It's a thing. But I'm going to shrink this down to 50%. Well, that's a little small. Let's go with, can we do 80%? How about that? So you can kind of shrink this window a little bit more and kind of cheat here. We can. This is what was on my wish list. And in fact, earlier videos I've had on WPF, I talk about my wish list of being able to pop out the XAML and have it on a totally different window from the designer. So have this tab and this tab not connected tightly. Well, now you can. There is a little button right here that says pop out XAML. So the good people at Microsoft or Santa, I'm not sure who, listened and heard my plea and added that little button. And I love that button. However, it's not necessarily demo friendly because I only record on one screen, even though I have three. So in real life, I would pop this into a separate window on a separate screen. But in this case, I really can't do that. I can't show you both. So I'm just going to kind of cheat and make this a little small, and then come down here and I'm going to add the font size. I'm going to set to be 18 across the entire form. That way we have a better visibility on our form. Okay, the very first thing I'm going to do, this is going to be a quick and dirty WPF application. It's not going to be necessarily pretty. So we're just going to make something that works. So I'm going to set up grid.row definitions without column definition, just rows. Row definition, a height of auto. And we're going to copy this and we're going to paste it. I'll paste it 5 times, and then the last one's going to be star instead of auto. What that does is it sets up 4 columns. They're going to have a height of auto, meaning if there's nothing in them, they collapse to nothing, which means I could have 30 rows and only use 3 and be just fine. That last one, though, is star, which means that it's going to use every bit of the available space left, which means we're going to have the blank space at the bottom of our form. So that's kind of like my crash course on rows inside WPF. Okay, after that, let's create a button. And we're going to give it a name, x:\name equals open connection. Let's spell it right there. And we're going to say this is on grid.row 0, which by default is anyways, but I like to specify it. Horizontal alignment equals center. Next row down, I'm going to say padding is going to be 20 and 10. That means it's wider than it is tall, the padding. And margin is going to be 20 all around. And let's close this out and say open connection. And there's our open connection button on our form. Remember, this form is only 80% of the actual size. Let me get 70. So even though it looks kind of tiny there, it's actually bigger than that in real life. That's going to be that button we're going to use to open a connection to our server. Next up, we're going to have a stack panel. Stack panels are great because we can actually just throw a bunch of things in there, in this case, 2 things, and they just arrange themselves. In this case, we want it to be an orientation of horizontal. And the grid.row is going to be 1. We also want the horizontal alignment to be centered. And I think that's it for stack panel. So we'll leave it on one line. And we're going to say, I want a text box. We'll give it a name of message. And the, let's call it message input. And the min width is going to be 300. The reason I said message input is because we also have the value coming from back from the server. When we the event, the name we give that string is message. So we have a string called message and also a text box called message. Could be confusing. That's where I call it message input. Okay, let's say the margin is going to be 20 on this, like so. And there's our text box. And then we're going to have a button. And in fact, let's copy this button. Nope, let's not. Yes, let's do it. I'm going to copy it. I'm not a huge fan of copy paste, but in this case, it just saves us some time. This is going to be a send message button. We don't need a grid.row because or the horizontal center, because of the fact that we're not in the grid anymore. We're in the stack panel, which is in the grid. We do need the same padding and margin on this button. And this is not going to be open connection. It's going to be send message. So you open the connection, you type your message in, we send message. You may say, well, Tim, wait a minute. What's the user? We're just going to hard code the user. Just say hey, it's from WPF client. All right. Next up, we're going to have our display of the messages. And for this, I'm going to use a scroll viewer. If you don't know, a scroll viewer allows you to have a scroll bar on something. If you don't have that, it won't scroll, but you might have things off the bottom of the form. So a scroll viewer, we're going to say grid.row is 2. And then the margin is 20, like everything else. And the max height, let's put it at 200. And the vertical scroll bar of visibility is set to auto, which means it won't show if it's not needed. Inside the scroll viewer is the stuff we want to potentially scroll. And that's going to be the list box. So list box, and inside here, we're going to give it a name equals messages. And the horizontal alignment, we want it to be stretched so it takes up the entire scroll viewer. And let's go to the next line here. And we're going to say padding is going to be, again, 2010 with space in between. And border thickness equals 0. I want border on it. And self-close that. So there's our list box with all of our stuff in it for our messages. So that's really all the code we need. I'm sorry, that's all the XAML we need to get this set up. Now let's go to our code behind, which gotta love all these usings we don't need. Let's add the usings we do need. So using Microsoft.ASP.core.SignalR.client. And we'll also have a using for system and a using for system.threading.tasks, I believe. And system.windows. Yep, I think those are the ones we need. Let's, just because we're being tidy here, I move it down. But also, just so you know, you can do the quick actions refactoring and convert to the file scope namespace. Kind of a nice little addition there. So now that we have this set up, we're going to open up a hub connection. So we have, first of all, our hub connection. We'll call it connection. This is our connection to our Blazor server hub. After that, inside of the constructor, the main window constructor, we're going to say connection equals new hub builder connection. Should look familiar since we did this already once. And we'll say dot with URL. And we give a URL. we're going to skip that for now. Actually, you know what? I think I know it. Localhost colon 7181, I believe is what I saw. And then it's chat hub. That's the full path to our server. And then with automatic reconnect. And then finally the build. Now, how do I know what this is for sure? If we go to our Blazor server and we go to properties and expand it, we see launch settings.json. Open that up and you'll see here for the Blazor server, which is our Kestrel environment, which is what we use by default. When we hit play, notice it says Blazor server. That's this name right here. So with that profile, we have two versions of our site. We have the HTTP version and the HTTPS version. But in program.cs, down here, we have the use HTTPS redirect, which means that if we launch the HTTP version, it's going to redirect to the HTTPS version. So instead of this, it is this, which is the HTTPS version, which is localhost 7181, and the ES is HTTPS. So HTTPS localhost 7181. So I did remember it. So that's that same connection that we did inside of the Blazor server project in the index page. So on the index page, right down here, we have the same connection. But this time we're just on a client. We're not on the server too. So we're just connecting to our client. And so we say, there's the URL. All right, so now we have our connection, but I want to show you a few extra things you can do inside here to make life a little better for you. So first one is we're going to look at three different events. So connection dot, the cool thing here is if you click down this little lightning bolt, show only events. Notice there's three events here. We have reconnected, reconnecting, and closed. So we're going to start with the reconnecting. This is if you aren't connected right now, but you're trying to reconnect. That's the with automatic reconnect. That's what's going to, when that's happening, you can know that because this event will fire. So we're going to add plus equal, which is going to add a new handler to this event. We're going to say sender, not comma args, just sender. And then we're going to have the arrow function, and then curly braces. And we're going to say this dot dispatcher dot invoke, and then arrow. And then inside here, we're going to say var new message equals attempting to reconnect, dot, dot, dot. And then we're going to say messages dot items dot add new message. And a semicolon at the end. And down here at the bottom, another semicolon. But we're not quite done yet because it says here, not all code paths return a value. Well, this is expecting to have a task be returned, but we're not doing anything asynchronous here. We could do the invoke asynchronously, or we can say, actually, let's just invoke async. And this return. Nope. Let's just, here. Instead of invoking async, which we can do, we can also just say return task.completed task. What this does is it says, hey, we're going to wait on this. Once we wait on this, then go ahead and complete this task and return that completed task. So this is just a constant, essentially, that returns a successfully completed task. And that satisfies our reconnecting. So what's happening here? Well, we're going to add this message to our list of messages. Where's the list of messages? Well, if you go back over here, we see a list box called messages. So we're adding it to our list box. So it's not just chat messages we'll see in that message box will also see attempting to reconnect if we lose a connection. Now, why did I wrap this inside of a this.dispatcher.invoke? Well, because this is an event and it can be fired on a different thread. So therefore, we don't know if we have access, if we're on the same thread as the user interface. Well, we are talking to user interface stuff. So I'm going to invoke this in order to make sure it invokes on the calling thread, on the UI thread, because that's the caller, the original caller. Therefore, we should have this added to the list. So with that being done, that's the reconnecting event. Now, let's do it 2 more times, essentially. Let's copy the whole thing and paste it again. But this time, instead of reconnecting, we're going to have reconnected, meaning we have just connected to our server. So I'm going to say, instead of attempting to reconnect, I'm going to say reconnected to the server. I'm also going to clear the items. So messages.items.clear will clear out previous messages. So if we reconnect to the server, I am going to clear out all the old messages and then put this message as the only message, and it says reconnected to the server. That's a cleanup thing you could or could not do. It's up to you. And then we're going to do this one more time. Let's paste this back in. We're going to call, and this is going to be a closed event. So we're going to do all 3 events here. And this one's going to say connection closed. Just tell us, hey, we're done. And we're going to add that message, but we're also going to do 2 more things. The open connection dot is enabled is going to be true. And the send message dot is enabled is going to be false. So we have 2 buttons on our form. We have the open connection and send message. We're going to make sure this one, open connection, is enabled, because if our connection's closed, we want the ability to reopen that connection. But because our connection's closed, we can't send messages. So let's disable the send message button. Now, this may give you a hint that we're going to swap that. Down later, when we open the connection, we're going to not allow the connection to be reopened because it's already open. And we're going to allow us to send messages because we are connected. So, in fact, we should set the is enabled on our send messages to false. So by default, we can't send messages. Okay, now we have that done, let's create some events. So let's create the open connection event. First, I can double click on this button and it'll create a new private void open connection _click and names it based off the button. And notice over here in my XAML, it adds this click event with this right here. I could have manually put click equals and put a name, and then it could have had it create this method for me, but double clicking is easy. So with this, we're going to say connection on string, if I can spell. And this is the receive message, comma, user message. And then we have our arrow. And in here, this is the same thing as what we did in our index page. Let's come down here, right here, same thing. So in here, I'll put a semicolon at the end to be complete, come back, and we're gonna say this, actually we can just copy, let's copy this one right here, this dispatcher.invoke. Same thing, dispatcher.invoke, and we're gonna say, instead of this new message being this, we're gonna say $. Let's use the same format we use on index.razor. So this. just message : user. That's it. We're going to add that to our messages items. So that will add that new message anytime we get the receive message trigger. So whenever does clients all send async receive message, this will trigger and will put this message, this user : message, onto our list of messages. And notice we're not wiping out that list of messages because we'd want to see one, then the next, and the next. We wouldn't want to have it wipe out things over and over. Now, we're not done yet on the connection click. Okay, so we've set up our connection with this event, but now we have to actually start the connection. But remember I said that we can wrap this in a try catch. And we'll catch the exception EX, and we're not going to throw it again. But if we have an exception, we're going to say messages.items, not .clear, items.add ex.message. And that's going to put the exception message onto our list of messages. Notice we don't have to wrap this in a this.dispatcher.invoke because we're on the UI thread. But in the try, we're going to say await connection.start async. So that starts the connection. And let's go ahead and say messages.items, not .clear. IntelliCode is nice, but it doesn't always know what I want to do. Add, we're going to say connection started, like so. So we're going to add that to our list of messages. And then we're going to say open connection dot is enabled equals false. So the connection is already open. So we're going to make sure that button is disabled so you can't try to open it again. But then we're going to say send message, which is the other button, is enabled equals true. So that button will be enabled. So the open connection button will be disabled. The send message button will be enabled as long as we successfully start the connection to the hub and we don't have any exceptions. So this just protects us in case we try to open a connection, it doesn't work, and then we wonder why everything's broken. Well, this would in fact throw the catch, and then we had that message in our list saying, hey, here's the reason why we couldn't connect to the server. Maybe it's not there. All right, so that's all we need to do for the open connection click. Let's go back up here, and we need to have the send message do something. Let's double click that. And a send message, we're going to wrap in a try catch as well. And again, we're going to catch the exception. And we're going to do the same thing. We're going to grab the messages.items.add ex.message. Paste it in there. And in here, we're going to say await, and we're going to say connection.invoke async. And we're going to say the send message. This is the one broadcasting out our message. So we're going to say a send message, and we're going to say it's from a WPF. Let's do this new line. It's from the WPF client. Remember I said we're going to hard code the user? Well, here's how we're going to do it. And then we're going to say message dot, not messages, message dot text. Oops, message input. Message input dot text. So we're going to grab the text box, and we're going to send that message to our hub. All right, that's all we need to do. We're all set up so that if we hit save and if we hit run, it's just going to run the server. So let's go back up to our solution, right click on it, and we're going to say set startup projects. Instead of a single project, we're going to set up multiple projects, and we're going to set the Blazor server and the WPF client, hit OK. So now multiple projects will start at the same time. Just wait. Let's save everything and rebuild. This normally works. but every once in a while, Visual Studio yells at me. Yes, enable AI assistant telecode. Sure. Cool. Great. Awesome. Thanks. All right. So it's saying, hey, we can't launch both of these, which is baloney. You can. Oh, it's not baloney. It's just Tim forgetting how to do things. So I have multiple startup projects. Let's zoom in here because the font's small. Multiple startup projects, but the action on both of them is none. So no, this is not Microsoft's problem. Sorry, Microsoft. This is Tim's problem. I said I need to say start on both of them. Hit OK. And now we're good to go. So let's bring this is the Blazor server. Let's shrink it down a little bit. And then let's also bring over our WPF connection. Let's first, on the WPF, notice we're not connected because it says open connection is enabled. Let's click it. And it says connection started. Cool. So if over here I say Tim and I say hello world, like so, and hit send, it says hello world on the WPF client and on the Blazor server project. But then on the WPF side, I can say hello Tim and hit send message. It says over here and over here on both sides, it says WPF client says hello Tim. So now we have a desktop app that is also a client of our server. So the server has to be web-based because it makes no sense to be just desktop-based. But the clients could be just desktop apps. Now, remember I said that the connection would retry? Let's go back without closing these. Let's go back and go to our solution. And we're going to right click on the solution and say open folder in File Explorer, which opens it over here. We're going to go to the WPF client. I'm going to open that up, go to bin debug .NET or net 6.0 Windows. I'm going to copy all of this. Open up a different folder. I'm going to say WPF. Inside here, I'm going to paste everything I just copied. Let's move this one off the screen. And now this is a copy of my WPF client. I haven't published it. This is a quick and dirty version. But if I open this up, I now have another WPF client. And I can hit open connection. My connection started, but notice I don't have the other messages that I had from the original one. Because this one just opened the connection. It's only been listening for a few minutes. But I can say, this is my standalone WPF client and hit send message. And notice it came over here. It came over here. It's also in the web server. We're not going to open that up. But if I move this off the screen for just a minute and I hit stop over here, notice it says attempting to reconnect. It's lost the connection to the hub, but it's trying to reconnect. Now, if I start this back up and I wait for a minute, this will be able to reconnect to our server if I didn't wait too long. There you go, reconnected to the server. I didn't do anything. I just waited for it and it's done. Now, the WPF app, the other one is open and I can connect. I've opened the connection, but now if I send the same message again, it gets the message. So this was the standalone project and it reconnected when the connection was lost. Now, if we stop this and wait 60 seconds, and I'll pause the video a minute, but it's going to transition from attempting to reconnect to closed connection. All right, it just closed the connection. So since it closed the connection, or the connection was closed because there was no way to reconnect it, it disabled the send message and re-enable the open connection. Now, I'm going to leave this like it is. I'm going to start this up again. And once it starts, I'm going to bring back over this client, and I'll bring over my web servers to show that it's actually doing it. And I'm going to say open connection again. Open connection, connection started, send message. It has connected to the server now that it's available again. So you can use these events to, for example, if you're disconnected or you can't connect or you're reconnecting and waiting for that, you could queue up messages. And once you reconnect, then you could start sending those messages from the queue and then get back to real life. So there's a lot of stuff you can do here that is pretty impressive. Now, I did say that I want to show you how to do a connection where we talk to the counter. So it's not just this send a chat message, but we're already pretty deep in this video. So what I'm going to do is do another video where we add on to this video, part 2, where we'll talk through, hey, let's create on the same app, we're going to create a new hub that is going to, instead of taking 2 strings, it's going to take a string and an integer, and that's going to change our counter from our WPF app or whoever calls it. So we'll do that in part 2. Until then, thanks for watching. If you have questions about SignalR, let me know down in the comments. If you want to see more about SignalR, then leave a comment down below. Let me know what your thoughts are and different things you want to see. But also go to suggestions.imtimcorey.com and upvote a SignalR suggestions there or add your own, because that's how I know if these video topics are what you want and how many people are interested in it based upon how popular they are. So I would definitely encourage going there, but please leave a comment down below as well, what your thoughts are on SignalR. That does help the video spread throughout YouTube and get more people interested in SignalR and get more people to understand how it works. All right, thanks for watching. And as always, I am Tim Corey.